2.3 and 2.4 trigonometric ratios. So trigonometry means triangle measurement. Okay, it's used to calculate the lengths of sides and measures of angles in triangles. When a right triangle is given, the following names of the sides are used. Okay, so we name the sides opposite, adjacent, and hypotenuse. So whatever angle we're talking about, so relative to angle, say x, this side would be opposite. That's the side that you can put an arrow through. 90 degrees to the opposite is the adjacent side, and the hypotenuse is the longest side. The hypotenuse is always across or opposite the 90-degree angle. Okay, so please note, we kind of just talked about this. Hypotenuse is always across from the right angle. The opposite and adjacent sides can actually flip, like this could be opposite and then this could be adjacent if we were talking relative to the other angle. Okay, so it all depends on what angle we're referencing. And we're never going to use the 90-degree angle as a reference angle. Okay, the following three ratios can be used when given a 90-degree triangle, so like a right triangle, to find the lengths of the missing side or measure of an angle. So we can use sine, cosine, oh, this is supposed to be tangent. Okay, so sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, tan is going to be opposite over adjacent. And we also use so, ca, toa. So if you look here, sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. Tan, opposite, adjacent. Okay, so whenever we say write SOHCAHTOA on your paper, that's what it means. Write this down and then we're going to reference it. Okay, this is going to be very, very useful. Now, when finding side lengths, the method of cross multiplication can be used. Okay, when finding angles, this is like on your calculator. On the calculator. What we want to do is we want to either press like the second or the shift button and then find and then press like either your sine, cos, or tan, the ratio that you're using. Okay, examples 1 and 2 are quick activities, just using your calculator, getting familiar with them. Okay, make sure you're in degrees mode. Okay, so a lot of times it'll have a D or an R or a GR. Okay, make sure you have the D there. Okay, so example 1, find each value to 4 decimal places. All you have to press is sine 48. If you have a backwards thinking calculator, you may have to input it as 48 and then press the sine button. Okay, so it depends. But definitely, I know that like a lot of us overlook little maybe like exercises like this, but it's actually important that you know how to work your calculator. Okay, and every calculator I find is different. So this one's 0.7431. Okay, if you press cos 71, we get 0.3256, and tan 32, 0.6249. Okay, so we tried one of each of these as an example. Now, find each angle measured to the nearest degree. So we have sine A equals 0.4226. Here's the thing. We're looking for A, so how can we reverse sine? We need to do something called sine inverse. So we're going to get A equals sine inverse 0.4226. This, just like referenced in like the box above, you either have to press second or shift and then press sine, and you should get 25 degrees. Okay, in this case, we're going to go tan inverse, right? As long as we're finding the angle, we need to inverse that. So we're going to have to press second or shift, and we get 80 degrees. And for C, A is going to equal cos inverse, 0.2588, So I get 75 degrees. Example 3. In the following right triangles, find the length of the indicated side. And we're going to find this to the nearest tenth. Okay, so in A, we have triangle ABC, and it looks like we're looking for x. So what we're going to do is relative to this angle, 43, we are going to name our opposite, and then this would be hypotenuse because this is across from the right angle. I mean, you can list the adjacent as well, that's totally fine. And what we're going to do is we're going to write down SOHCAHTOA because we need to decide which trig ratio out of sine, cosine, and tangent we're going to actually be using. So let's think about this. So 43 goes with the trig, so sine, cos, or tan. We need the opposite, so we need opposite, and we're given the hypotenuse, so we're given this. Okay, if you can see, we should be using sine because we have 2 out of the 3. We only underlined the H here and the O here, so we're not going to use those. We're going to use sine of the angle equals opposite over hypotenuse. So our angle is 43, sine of 43 equals opposite is x, hypotenuse is 67. Let's go ahead and cross multiply that 67 up. And we're going to put 67 sine 43 into our calculators. And we get 46 degrees. Sorry, that's going to be 46 centimeters because it's the opposite side. Okay, so a lot of steps here. Let's try again for B. So identify the angle that we're using, which is 48. This side is opposite. This side is, opposite and adjacent meet at 90 degrees. So this side is adjacent, and this is our longest side, our hypotenuse. So let's write SOHCAHTOA and see what we need. So we have an angle, and then we're given the adjacent, we want the hypotenuse. So we're given the adjacent, we want the hypotenuse. Okay, we're going to use cosine because we have 2 things underlined there. So cosine of r, that's our angle, is going to equal adjacent over hypotenuse. So our angle is 48 degrees, our adjacent side is 121, and our hypotenuse is x. So this one's like a 2-stepper. We're going to cross multiply the x up. We get x cos 48 equals 121. Now what we're going to do is divide both sides by cos 48. Those cancel. We get x equals, we're going to divide 121 divided by cos 48. We get x equals 9.4 centimeters. Okay, and the last one, C. Okay, so identify the angle we're using, and now label the opposite, the adjacent, and the hypotenuse. Write out SOHCAHTOA. We are given the opposite, we want the hypotenuse. So sine, cosine, or tangent. Sine has opposite and hypotenuse in there. So we're going to go sine of m equals opposite over hypotenuse. So we have sine 61, we sub that angle right in where the m is. We have 15 over x. This is that 2-stepper. First we cross multiply x up. X sine 61 equals 15. Then we divide out the sine 61. So we get x equals 15 divided by sine 61, which we get 8.3 centimeters. Example 4. In the following right triangles, find the measure of the indicated angle. So this time, instead of finding the side lengths, we're finding the angles. So identify the angle that we're using in A, so that'd be X. We're going to label this is opposite. 90 degrees to the opposite is the adjacent. And then we have the longest side, which is the hypotenuse. So when we write out SOHCAHTOA, we're given opposite, we're given hypotenuse. The trig ratio with opposite and hypotenuse is sine. So we're going to go sine x equals 4. Let's just do general right now. Opposite over hypotenuse. So we know sine x equals 4 over 12. Now, in order to solve for the angle, we have to put x equals. So instead of doing a sine, we're going to sine inverse this number. And we're going to get 19 degrees. Remember, sine inverse is shift or second on your calculator, and then sine. Okay, B, identify the angle that we're using. Label the opposite, the adjacent, and the hypotenuse. Okay, so writing out SOHCAHTOA, we're given the adjacent, we're given the hypotenuse. That means we're using cos. So cos x is going to equal adjacent over hypotenuse. Okay, the adjacent side is 12. Sub that in. The hypotenuse is 21. Now we're going to, instead of cos, we're going to cos inverse this number. Okay, when you put this in your calculator, remember to put brackets around this number, or actually just do the 12 divided by 21 first, and then cos inverse it. Okay, you got to make sure that we're cos inversing this entire number. Okay, and you'll get 55 degrees. Okay, last one, C. Identify the angle that we're using. We're going to label opposite, adjacent, and hypotenuse. So when we do SOHCAHTOA, we are given opposite and we're given adjacent. So we're going to use tan. So tan x is going to equal opposite or adjacent. Okay, so tan x equals the opposite is 11 and the adjacent is 15. So instead of putting tan in our calculator, we're going to tan inverse the 11 over 15. And remember to bracket the 11 over 15. And you're going to get 36 degrees.